For years, the promise around AI was simple. Machines get smarter, work gets faster, and prices eventually come down. That's how technology has usually worked. Computers got cheaper, phones got cheaper, software got cheaper to build and cheaper to distribute. So when AI exploded onto the scene, most economists expected the same pattern. AI would boost productivity, companies would do more with fewer people, costs would fall, and eventually that savings would trickle down to consumers. Nearly every major forecast repeated some version of this story. AI is deflationary. AI lowers costs. AI makes everything cheaper over time. But something strange has been happening instead. Prices for the things AI actually depends on have been rising sharply, and in some cases at rates nobody predicted just 2 years ago. To understand why, you have to look past the chatbot on your screen and into the physical infrastructure quietly holding the entire industry up. AI doesn't run on ideas, it runs on electricity, silicon, and human expertise. And every one of those three things has gotten more expensive, not less, since AI adoption took off. Chapter 1. The Promise. The theory behind AI-driven deflation made sense on paper. Automate repetitive work, and companies spend less on labor. Spend less on labor, and prices for goods and services should eventually fall. Economists pointed to earlier waves of computing. Personal computers got dramatically cheaper over a few decades. Cloud computing made enterprise software far more affordable than it used to be. The internet itself crushed the cost of distributing information almost to zero. That's the pattern everyone expected AI to follow, a technology that starts expensive and specialized, then gets cheaper and more widely accessible over time. AI looked like the next chapter in that same story, a tool that could write code, answer customer service tickets, analyze documents, and generate content, all of it without needing to hire more people to do it. If that held true at scale, it really could have been broadly deflationary. Less labor cost baked into everything from customer support to marketing to basic office work. Major investment banks published reports predicting exactly this. Some forecasts suggested AI could shave meaningful percentage points off inflation over the coming decade simply by making entire categories of labor dramatically more efficient. The problem is, that theory assumed AI itself would stay cheap to run. It hasn't. And the reason has almost nothing to do with the software itself. It has to do with what the software needs underneath it. Chapter 2. The Electricity Problem. Every AI model, from a simple chatbot response to a massive training run, needs electricity. Not a small amount either, a genuinely enormous amount. Training a large frontier model can consume as much electricity as tens of thousands of homes use in a year. And that's before accounting for the electricity needed just to run the model afterward, every single time someone sends it a query. A single query to a large AI model can use roughly 10 times more electricity than a standard search engine query. Multiply that by billions of queries a day, across dozens of companies racing to build bigger models, and the scale becomes genuinely staggering. Data centers built specifically for AI have exploded in number over the past few years. Each one needs a stable, massive electricity supply, running continuously, not just during business hours. Some of these new campuses require as much electricity as a mid-sized city, running around the clock every single day of the year. The problem is, the US power grid wasn't built for this kind of sudden demand. Electricity infrastructure takes years to plan and build. AI data center demand arrived in a matter of months. Building a new power plant or significantly upgrading transmission lines typically takes somewhere between 5 and 10 years from planning to completion. AI data center construction has moved at a completely different speed, sometimes going from announcement to operation in under 2 years. The result has been a genuine supply crunch. Utility companies in several states have had to delay other planned projects just to prioritize data center power requests. Some developers have started looking at building their own dedicated power plants rather than waiting for the existing grid to catch up. In some regions, data centers now represent the single largest source of new electricity demand utilities have seen in decades, larger than population growth, larger than industrial expansion, larger than the electrification of vehicles combined. Natural gas plants are being proposed specifically to serve individual data center campuses. Nuclear power, largely abandoned as a growth industry for decades, is suddenly being reconsidered, with tech companies signing deals to restart previously shut down reactors just to secure guaranteed electricity supply. That alone tells you something about the scale of the problem. Plants considered too expensive and too slow to matter just a few years ago are being brought back online because tech companies are willing to pay a premium for guaranteed, always-on electricity. All of that new demand pushes up the price of electricity itself, not just for data centers, but for regular households and businesses sharing the same regional grid. In several states with heavy data center construction, electricity rates have already started climbing noticeably faster than the national average. Some residents in these regions have noticed the difference directly on their monthly utility bills, well before ever personally using an AI product. You don't have to use AI at all to feel its cost. You just have to live near the infrastructure that powers it. So the very first input AI depends on electricity has gotten more expensive, not cheaper, as adoption has scaled up. Chapter 3. The chip problem. Electricity is only half the equation. The other half is the physical hardware needed to actually run these AI models, and that hardware runs on a very specific, very limited supply chain. AI models need specialized memory chips called HBM, high bandwidth memory, to move enormous amounts of data quickly enough to keep up with modern AI processors. Standard memory chips, the kind found in ordinary laptops and phones, aren't fast enough for this job. Think of it like a highway system. A regular memory chip is a normal 2-lane road, fine for everyday traffic. HBM is a 12-lane superhighway, built specifically to move an enormous volume of data without creating a bottleneck. AI processors need that superhighway, or the expensive processor itself just sits there waiting. There are only a handful of companies in the world capable of producing HBM chips at meaningful scale. SK Hynix, Micron, and Samsung together control the overwhelming majority of global supply. As AI demand exploded, all three companies started redirecting production capacity away from standard consumer memory chips and toward the far more profitable AI-focused memory instead. AI data centers were willing to pay significantly more per chip than ordinary consumer electronics manufacturers ever had. If a chip factory can sell the exact same production capacity for 10 times the profit margin by making AI memory instead of consumer memory, that factory shifts production toward AI memory. Capital always flows toward the highest bidder, and right now, AI companies are the highest bidder by a wide margin. That shift created a genuine shortage in regular memory chips too, the kind used in everyday laptops, smartphones, and other consumer electronics. Memory prices across the board have surged as a result, in some cases more than doubling within a matter of months. This is part of why some major electronics companies have had to raise prices on ordinary consumer products mid-year, something they almost never do outside of a new product launch. The reason wasn't new features or added value. It was simply that the memory chips inside those products had become dramatically more expensive to source. The exact same laptop, same design, same components, same factory. Yet the final price to the consumer goes up purely because one specific component inside it has become scarce. That's exactly what's been happening across the electronics industry. So a technology marketed as making things cheaper has, in the short term, made a core physical component more expensive across an enormous range of everyday electronics that have nothing to do with AI at all. Chapter 4. The labor problem. Here's the part that seems most contradictory to the original deflation story. AI was supposed to reduce labor costs. Instead, in one very specific and very expensive corner of the labor market, it has done the exact opposite. Engineers with genuine expertise in building and training large AI models are in extremely short supply. There simply aren't enough people in the world with the specific skills needed to build frontier AI systems at the level top labs require. We're talking about a genuinely tiny pool of people globally, likely numbering in the low thousands, who have the specific combination of mathematical background, engineering skill, and hands-on experience needed to meaningfully advance frontier AI research. Every major lab in the world is competing for the same small group of people. That scarcity has pushed compensation for top AI researchers and engineers to genuinely extraordinary levels. Total compensation packages for senior AI talent at major labs now regularly run into the millions of dollars annually, numbers that would have sounded absurd in almost any other engineering field just a few years ago. There have been reports of individuals signing bonuses alone before any salary or equity, reaching 8 figures for a single researcher moving between major labs, tens of millions of dollars purely as an incentive to switch companies. Companies aren't just competing on salary either. They're competing on access to computing power itself. GPUs, the specialized chips needed to train and run AI models, remain in short supply relative to demand, and top researchers often choose where to work partly based on how much computing power they'll actually have access to. In this world, computing power has become a form of compensation in itself. A researcher might genuinely choose a lower salary at one company over a higher salary at another, simply because the first company can offer significantly more computing resources to actually do the work. That scarcity ripples into cloud computing pricing too. Renting access to powerful GPUs through major cloud providers has gotten significantly more expensive as demand has outpaced available supply. Companies building AI products on top of these cloud platforms are absorbing those higher costs, and in many cases passing at least some of it along to their own customers. Startups building AI-powered products have reported their cloud computing bills climbing dramatically year over year, sometimes becoming their single largest operating expense, larger even than payroll. Meanwhile, companies across nearly every industry are pouring enormous amounts of capital into AI infrastructure and talent, regardless of whether they've figured out a clear, profitable use case yet. That kind of aggressive, competitive spending tends to push costs up broadly, across an entire sector rather than down. Chapter 5. The inflation nobody expected. Put all of this together, and a strange picture emerges. Electricity costs are rising in regions with heavy data center build-out. Memory chip prices have surged across consumer electronics. Elite engineering talent commands historically unprecedented compensation. Cloud computing costs are climbing for companies trying to build AI products. None of this looks like the deflationary story that was originally promised, and it's showing up in places you wouldn't necessarily expect to check. Software subscription prices have started climbing at companies that have built AI features into their products, since running those AI features costs real money behind the scenes. Some services that used to be effectively free are introducing new paid tiers, specifically to cover the computing costs of their AI features. A company adds a new AI feature specifically to make their product more valuable and more competitive. And the direct result for the consumer is often a higher monthly bill, not a lower one, because that feature costs real money every single time it's used. At a corporate level, capital expenditure on AI infrastructure has become one of the largest single categories of spending among major technology companies, running into the hundreds of billions of dollars annually across the industry as a whole. That spending has to be funded somehow, whether through existing profits, new debt, or new equity raised specifically for this purpose. Some of that spending is increasingly funded through corporate debt. And as more companies compete to raise money for AI infrastructure at the same time, borrowing costs across the sector have started climbing too. That, in turn, connects back to the broader bond market and interest rate environment overall, since a large enough wave of corporate borrowing can influence borrowing costs more broadly across the economy. This is where the story stops being just a tech industry story and becomes a genuinely macroeconomic one. When enough large companies borrow enormous sums at the same time, it doesn't just affect those individual companies. It affects the price of borrowing money for everyone else too, including ordinary households trying to finance a home or a car. Central banks now find themselves in a genuinely strange position. Historically, when new technology drives major investment, it eventually translates into lower prices for consumers. And that's exactly the kind of disinflationary pressure that gives central banks more room to work with. But AI's investment boom right now looks more like a temporary source of inflationary pressure instead, driving up costs for electricity, hardware, and skilled labor, all at the same time, before any of the promised efficiency gains have fully materialized on the other side. None of this means the original promise of AI was wrong. The technology genuinely can make certain tasks dramatically more efficient, and over a long enough timeline, that efficiency really could translate into lower costs in plenty of areas. But that outcome depends on the infrastructure catching up first. Enough electricity generation coming online, enough chip manufacturing capacity built out, enough trained engineers entering the field to ease the current talent shortage. All of that takes real time, measured in years, not months, since none of these constraints can be solved with more funding alone. In the meantime, the technology everyone expected to make things cheaper has, for now, been doing something close to the opposite. AI may eventually make everything cheaper, but before that happens, it could make almost everything more expensive.